This segment's about tripods. The application of tripods is to create a high directional or a point that buys you more space and makes your access into areas easier. There's some basic fundamentals about tripods that need to be followed, otherwise you get into more in-depth rigging. We're going to talk about both of those options today and the different systems that you can build utilizing a tripod. The first fundamental is utilizing the center mass point of the tripod as your directional point, not articulating the tripod in any way, shape, or form. When you erect tripods, most of them have letter indicators or marking indicators so that you can ensure that your legs are extended to the same height. As long as you're working on a flat plane, that'll ensure that you're operating at a center point with your load. If you have to short jack one of the legs, or if you have a deviated plane, you got to be conscientious to step back, take an overall objective view of the tripod, put a basic simulated load on it, and ensure that you're not causing it to shift in one direction or the other. So center mass is that first priority. Before you extend the tripod, and we always want to buy as much space as we can when we erect tripods, you might as well rig all of your components to the primary anchor points. It's good to use a large knot passing or directional type kootenai carriage to give you the opportunity to run multiple items through it. It's better to have it in place initially than to have it as an afterthought and have to unrig and then re-rig things. You also want to make sure that you don't hard link this, so it's also wise to integrate a swivel before you get started. Make sure that you're using G-rated components for this directional. Tripods are equipped with a chain that runs around all of the bases, connecting each foot pad to one another. Once we were to fully extend this to the height desired, we'd want to make sure that the link was relinked in that chain so that it was relatively taut, so that the legs wouldn't extend any further than what we initially planned them to. Before you would run your line, fully extend this and prep it for actual entry or over the edge operations, you need to make sure that the feet on the tripod are pinned. If you're working on a hard surface like asphalt or concrete, obviously that's going to require hammer drilling and possibly bolting or pinning. Most of the foot pads on tripods accommodate half-inch product, so half-inch rebar works really well, especially if you put like a shepherd's crook on the top of it. Drive that, make sure that both ends embed into the soil, drive them at slight angles of opposition, and you'll have good stable anchor points for the foot pads on the tripod. If your entry point or your edge does not meet the criteria that's going to allow you to keep your tripod center mass, then we're going to be articulating the tripod. When we articulate, we're assuming that our edge is along this line or our entry point is along this line, and we can't get over that entry point. You're going to accomplish that by extending your back leg, transferring the center mass load point to a more forward position to allow for a descent in that area. When you do this and articulate these, you want to have kind of a point of no return. So there should be a general line along the front line of these legs that you're not going to extend this head point past. And it's basically a perpendicular point in space directly above the position or plane of the front 2 feet. Once you're in line with that front plane, you're now ready to continue your rigging. There are some tripods that allow for more dramatic articulations, but require much more invasive foot pinning. For most of your procedures, these are about the limits or the restrictions of as far as you're going to go with your tripod operations. From this point, because all of our load or force is generating lateral forces in this direction, we need to resist those forces by implementing tension back ties in opposition to that load or that lateral force.